Okay, so I kind of found like the first kind of computational and one of the more difficult uh, problems.
Mm-hmm.
And that would be number 6. So this is on 3A. And then number 6. And this one says if John earns 20% more than Mary, then Mary must earn 20%. 20% less than John does. And so what you're wanting to do is either say this statement makes sense or this statement does not make sense. And so to determine that, what the best approach here, there's Aiden coming.
Oh, yeah.
Hey there, Aiden, can you hear me?
Yep.
All right. Do you have any trouble getting in, or are you just running a little bit late?
Just a little bit, but my Wi-Fi's also been acting weird. So
Well, I had a little bit of issue to start, so that wouldn't have affected you. I had a firewall kick up, and I think it caused some problems, but I was able to go around it. All right. So here's the deal, and so and this would include you on this, Aiden, in terms of just being a little bit behind still. And I know things are crazy. Kyle and I were just talking about that. So Natalie can't be here because of some family stuff, and I'm not sure about Casey, but I'm not going to do anything new tonight. We were just going to work some problems, and so Kylie wanted to see some of the percentage problems out of 3A, so that's what we're doing right now. I am recording, so and we're looking at number 6 on 3A. So if you have any problems you can think of, you want to go over anything on the quizzes or homework, feel free. Now's a good time to ask. All right.
okay, yeah, I'm just a little bit behind on that stuff.
So
My week's been crazy so far.
I understand. So my hope is between now and then next Tuesday, you can get yourself, caught back up a bit. So at least through the, up through to this section here at 3A. But we'll talk a little bit more. So anyway, let's go ahead and look at this problem out of 3A, number 6. So it's just a statement, and does it make sense or not? If John earns 20% more than Mary, then Mary must earn 20% less than John does. All right. So approaching this, all right. So what we want to do here is actually just use some actual numbers to reflect this statement. So it says John earns 20% more than Mary. So what I could do is if he earns 20% more, I could start with an amount, say 2,000. Let's just say $2,000, arbitrary amount. Now, I could take this and multiply it by 20%. Figure out what 20% of 2,000 is. Now, so that would be multiplied by 0.2, which would be $400. So if I've had 2,000 here, that would be 2,400. I added the 400 to this. So let's presume that's Mary and this is John. So that he would earn 20% more. So what we want to kind of think about is where that what we call the relative difference or relative change. So remember the absolute difference or absolute change was just simply new value minus reference value, or in the case if we just call it looking at the absolute relative difference, it's still the same calculation, just a little change of wording. But so we could say compared value minus reference value. That's the absolute difference. Then the relative difference, which is as a percentage. That's going to be your compared value minus your reference value divided by your reference value. It's always divided by that reference value. Now that's going to give you a number in decimal form, which then you could move the decimal place 2 places to the right and have it as a percentage. So for us, of this problem, I then could say, well, take my numbers here, saying John makes 2,400 and Mary makes 2,000. So watch how it works out. Compared value, I'm comparing it to John earns 20% more. So we're just making sure that that in fact works out for us. Comparing it to Mary's. Now, if you do this calculation, you get that minus that. So that's going to be 400. Divided by 2,000. Which if you punch that up on your calculator, you're going to get 0.2. Or so comparing John's to Mary's, there's that this part right here is now true with these numbers. John earns 20% what? More.
More.
And again, I picked the numbers out of thin air. I just picked 2,000. It was a nice round number. Said, well, if I wanted then, make his amount be 20% more, I figured up what 20% of this was and then added that to the 2,000. So that's how I got the numbers, but it did work out. But then we're saying, does this statement make sense? So if these are the two numbers, and we just worked it out for sure that he makes 20% more, if I then switch and saying, okay, that Mary must earn 20% less, now she's the compared value, which is 2,000. And the reference value is what John makes, 2,400. And then you would divide by the 2,400 because that's now the reference value. Well, this works out to be negative 0.1 yeah, I believe so. Should be 6 repeating. So negative 400 divided by 2,400. Yeah, so it's negative 0.16, and then that 6 is repeating forever and ever and ever. So if I round this to turn it to a percentage and round it to tenths place, I'm going to get negative 16.7%. That's, again, we're rounding, so we'll put a little squigglies here. But it's clearly not what 20%. She's not earning 20% less. She is earning negative 16.7% less.
Mhm.
And if, as long as the numbers were such that John made 20% more, she's always going to make negative 16.7%. And so one of your choices out of the four says the statement does not make sense because if John earns 20% more than Mary, then Mary must earn approximately, and because we rounded it, 16.7% less than John does. All right, so that one's a little tougher problem, just because you've got to come up with, the best way to see it is to make up some numbers, but then do the comparing and reference value calculation here, making sure he earns 20% more, but then using those same numbers, she's going to earn that much less. All right, any questions on that one?
I don't think so.
Hayden?
No, I'm good.
All right. Can you think of another one in there?
No.
All right. I tell you what, it's kind of flipped up a little bit. And so unless you can think of the problem, I'll just kind of randomly pick
Okay.
one. So now I'm looking at number 10. All right. In this one, you're going to express a percentage as a reduced fraction. It gives you 107. So this is just kind of basic working with percentages. So if you have 175%, you want to type this as a simplified fraction, then first write it as a fraction. So remember, it's always per cent or per 100. So this is equivalent to 175 over 100. But then it's reduce it. And so looking for common factors between top and bottom. I know 25 will go into the top and the bottom. 175 divided by 25 is 7. And 25 divides into 100 4 times. And so your answer here, 175% as a fraction in reduced form is 7/4. Any questions on that?
I don't think so.
Okay. I would also ask you to put this in decimal form. So remember on that, if you have it as a percentage, then you want to move the decimal place, in this case, 2 places to the left. If it's already in percentage form, then as a decimal, 2 places to the left. If it's in decimal form, then 2 places to the right. So in decimal form, it would be 1.75.
I'm sorry. Can you repeat the last part? My video is reconnecting.
Yeah, so there were actually 2 parts to this question. One was to write it as a fraction. We did that. And the second part was write it in decimal form. And so
Okay.
if the number, if you have it in percentage, then that decimal point is always behind the last non-zero digit, which here, if you don't see it. But this, to put it in decimal form, it's always moved to the left 2 places. That's why when I went 20% and I did that first calculation, I multiplied to figure out 20% of something. I multiplied by 0.2. I've literally moved it 2 places. All right, so there it is as a decimal. So 175%, the decimal setting here, move it 2 places. And so 100, basically, these are all equivalent. What we're saying. Is that good?
Yeah, that makes sense.
Mm-hmm.
Aiden, you good?
Yeah.
All right. And there's another one like that. Now look at number 12. 12 says, what is the decimal form of, and it gives you a fraction, in this case of 13/8. So what you want to do is fraction is always top divided by bottom. Take your calculator and go 13 divided by 8, and it comes out to 1.625. And that would be the decimal form. So you literally will type in 1.6, 25. Make sure I'm seeing that right. And then it asks for the percentage. So you can always, and so what we're seeing is any number we can write as a fraction, or we can write as in percentage, we can write it as in decimal forms. They're all equivalent. We want to be able to move, through any of the three forms. So if you're in decimal form, remember to put in percentage. As a percentage, you want to move to the right twice. It's always twice, either left or right, depending. So from decimal to percentage, I'll move it twice here. And I've got 162.5%. Of course, it gives you the percentage. All you got to type in is 162.5.
So you don't want to round that up.
No, unless
Okay.
it says in the blue where it says, it always tells you how to give an answer. Unless it says give as a whole number. This one says type as an integer or a decimal. And that tells me to go ahead and leave that 0.5 there. So just move it twice and don't round unless it specifically tells you to. Okay. So we did one, I think we did this next one as in, but it's worth doing again. And so number 13. And this one, it says compare A and B in 3 ways. So gives you numbers. For A, it says and these are deaths, number of deaths for the deadly disease in 2005. 51,823. $51,823. And B is the number of the same number of deaths to the same disease in the year 2009. And that number was 17,000. 17,789. Now it asks, type in ratio. What would the ratio of A to B be? What would that ratio be? And so to answer that question, you're going to first write this as a fraction. And it literally goes, when you write ratio of A to B, this is as a fraction, numerator to denominator, top to bottom. And so as a fraction, it's 51,823 divided by 17,789. And then you just put this in your calculator and do the division. Because it asks for this number to be as an integer or decimal rounded to 2. So it tells you to round to 2 decimal places. So it doesn't ask you to put it in as a percent, just in decimal form. So 51,823 divided by 17,789. And so rounding, now you get 2.913204789. So, but putting this in as a decimal rounded to 2 decimal places then would be 2.91. And B asks for ratio of B to A. Now, so here, and it's just the opposite. It's 17,789 up top to 51,789.
Oh, okay, so you're just flipping them.
You flipped it. So
Okay.
it literally, when you read ratio of whatever to whatever, that's going to be this first one. As you go this to this, this is your top, this is your bottom.
Okay.
And so the ratio of deaths of 2009 deaths to number of deaths in 2005, then is just the reverse. So you go 17,789 divided by this time 51,789. Now again, rounding to 2 decimal places, you would round this to 0.34. It's like 0.34348999303. But again, it tells you to round to 2 decimal places. Now the last question then says A is blank percent of B. Now, same deal. When you read this, this is like if it says ratio of A to B, if it says A is what percent of B, you take this, literally what you're doing in this question is you're writing it that third way. So if I take 2.91 and write it as a percentage, remember you move it twice and put the percentage sign on it.
Mhm.
So A is 291% of B. And that would be that. And it makes sense. So A would be 291% of B. A is definitely what you can tell it's more than twice the size of B. The
Mhm.
numbers are much bigger. Right, any questions on that one?
I don't think so.
All right. So and the rest of them are pretty much kind of all the same. So the very beginning problems in 3A are just the definitions of absolute change and relative change, which is its percentage, and just always making sure when you find relative change, you go new or compared value minus your reference value divided by your reference value. And you'll get a decimal number. Then you can write it as a percentage by moving the decimal place 2 places to the right. So, all right, can you think of anything else?